Hello everyone, welcome back to my channel Saisha. This is Amogh Kaliwal. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood binomial distribution, applications of binomial distribution and comparison of binomial distribution with other distributions. In today's video, we will understand Poisson's distribution, applications of Poisson's distribution and why to use Poisson's distribution and where to use Poisson's distribution. Poisson distribution. Poisson distribution is a tool that helps us to predict the probability of a certain event when we know how often that event has occurred. For example, from the past decade, yearly we have 250 centimeter of rainfall in Delhi. Now we want to understand the probability of occurrence of 300 centimeter of rainfall in 2021. Or there were 60,000 to 70,000 positive COVID-19 cases daily from the past week. Now what is the probability we will have 50,000 COVID-19 positive cases tomorrow? The formula, that is the probability density function for Poisson's distribution, would be represented as P of x is equal to n, where x is a random experiment, n is the number of events, which is equal to e raised to minus lambda into lambda raised to n divided by n factorial, where lambda represents how often the event has occurred, that is mean or average of the event occurrence, and n represents the number of events. Now let us understand when to use Poisson's distribution. We can use Poisson's distribution in two cases. The first case is if the individual events are occurred at a random and independently in a given interval. This interval might be a time or a space. In the second case, if we know the mean number of occurrences in the interval, that is the rate of occurrence is in a finite interval, then we can use Poisson distribution. As we have understood where we can use Poisson's distribution, now let us compare the different distributions with Poisson's distribution. Let us compare four different distributions, that is Bernoulli's distribution, geometric distribution, binomial distribution and Poisson's distribution. Bernoulli's distribution, it is a random experiment that has two outcomes. Example, tossing a coin, we have head or tails. Geometric distribution, it is for estimating the number of attempts before first success. For example, the number of choco packets I should open before I get a toy. Binomial distribution, for estimating the number of successes in n attempts. For example, if I am a goalkeeper, I have 10 attempts, then how many goals I will be able to stop. Poisson's distribution, for estimating n number of events in a given time interval when on average we see m events. For example, if 10 buses pass through the bus stop in 1 hour of interval of time, then what is the probability in the next 1 hour we will get 11 buses. Now let us understand few of the applications of Poisson's distribution with examples. In first example of Poisson's distribution, a student is preparing for exam. He has not done his revision for the exam. Hence, he wants to guess the answers for each of the questions. The probability of getting the question right is 0.05 and there are totally 50 questions. Now we want to identify what is the probability that he will get 5 questions right out of 50 questions. To analyze this, the probability P is equal to 0.05 and there are totally 50 questions in the exam. Hence, on an average, there are 2.5 questions which are getting correct out of 50 questions, which is multiplication of probability into number of questions. Now, we want to know exactly 5 questions he will get right. Hence, n is 5. The probability density function formula which we will utilize is P of x is equal to n equal to e raised to minus lambda into lambda raised to n divided by n factorial, where lambda is the average number of occurrences and n is the number of occurrences. Substituting the values into the formula, P of x is equal to 5 is equal to e raised to minus 2.5 into 2.5 raised to 5 divided by 5 factorial. By calculation, we get 0.067 as the probability density function for x is equal to 5 from Poisson's distribution. That is, the student has 6.7% chances of getting 5 questions right out of 50 questions. Now, let us understand example 2. In the second example, we want to analyze the storms hitting a city in US. On an average, 2 storms hit the city in a year. Now, we want to identify the probability that 3 storms will hit next year in the city. To analyze this, we have lambda is equal to 2, n is equal to 3, which means on an average 2 storms will hit, and what is the probability that 3 storms will hit next year. We have the formula P of x is equal to n, where x is a random experiment, n is the number of events, which is equal to e raised to minus lambda into lambda raised to n divided by n factorial. Substituting these values into the formula, we have probability density function for x is equal to 3 is 0.18, which means 18% chances that 3 storms will hit the city next year from Poisson's distribution. Now, let us understand the third example of Poisson's distribution. In the third example, we are analyzing turning up of a bus at a bus stop. On an average, one bus turns up at a bus stop in a 15 minutes interval. Now, we want to identify the probability that no buses will turn up in the next 15 minutes. To analyze this, the lambda is equal to 1, that is one bus turns up in every 15 minutes. Now we want to identify that 0 buses will turn up in the next 15 minutes interval. The probability density function of Poisson's distribution is P of x is equal to n, which is equal to e raised to minus lambda into lambda raised to n divided by n factorial. Substituting these values into the equation, we get probability density function as 0.368, which means we have 36.8% chances that no bus will turn up in the next 15 minutes interval. These are some of the applications of Poisson's distribution. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.